Hi, in this video, I want to show you how to take an absolute value function. So if there's an absolute value of a regular function that you know, what happens to it. I'm only going to do one example, but we'll try to assess what happens after that. And if you're in calculus, then you can take its derivative piece by piece and do it wisely. The example I'm going to go through is f of x is equal to the absolute value of x squared minus 4. So let's first of all look at x squared minus 4, and here's the picture. It's a parabola. The intercept here is -4. That's what it should be, and this is our shape. Now when we take the absolute value, what's going to happen is that all these values that are below the x-axis are going to become positive. So everything down here is going to flip up and be right here. And so let's see what that looks like. And sure enough, that's what we have. And so in the blue here is still y equals x squared minus 4, but in the black now is the absolute value function. And that's our f3 that I was talking about. And if you notice, everything that was below the x-axis before, after we take the absolute value, will be above the x-axis now. Now what happens with this is that we end up with what we call 2 or 3 pieces, honestly. This piece on the outside and this piece on the outside both belong to this function, which is x squared minus 4. However, this piece in the middle, which looks like an upside down parabola, or part of it, that piece does not belong to x squared minus 4. In fact, it belongs to negative x squared plus 4. And so we change both signs of the absolute, what's inside the absolute value function. So what we can do with this is we can split this into 2 different pieces, and that's what we want to do. One piece is going to be simply x squared minus 4. That's the piece that looks the same. And then the other piece, it's going to be exactly the opposite. So we're going to change both signs in here, -4 plus x squared. Now the only thing is we got to figure out which intervals this occurs on. Now remember that this bounce point for absolute value functions will be at the zeros of what's inside. So if I take the zeros, I hope you can see that this is -2 and 2. Find the zeros of this function. Those are going to be my bouncing points. So the question is when is my function looking like x squared minus 4? Well, it's going to be outside of -2 and outside of 2. And we can write that a couple different ways. We can put it together, or else we can use an absolute value function. So this one occurs on the interval where the absolute value of x is greater than or equal to 2. And what that means is that my distance from 0 is greater than or equal to 2. Oh, here's 0. My distance greater than or equal to 2 is out here. And my distance greater than or equal to 2 is out here. So that should work. Then when does this function occur? Well, this function occurs in between -2 and 2. Now you might ask, why did I put the equal sign here and not here? You choose. I could have put it both here and not here, or I could put it here and then not here, but choose one of them. And I just made a choice that I decided this one. Okay, so this is how you'd split it up into piecewise functions. Now going back to our graph, what we can do is look at this even a little bit more. This is the function that we have. If I go ahead and graph another function, how about if I graph this -x squared plus 4? What's going to happen, and what is this going to look like? Well, it's going to fit right over this piece right here. So if I change both of the signs, then I should be pretty good with what's going on. And when I say change both the signs, it's all the signs that were inside the absolute value function. So this green layer on top represents this piece that's right in the middle. And so then I can talk about my piecewise function like this right here. So this is how I split it into pieces. So finally I can graph this. So I can go to a graph page, and on the Inspire I can split it up into pieces. Here it is. I'm going to do 3 pieces rather than that absolute value interval. So if I do 3 pieces, I'm going to end up with, so I just started typing this in. I got x squared minus 4. What interval is that on? It's for x less than or equal to -2. 4 minus x squared, and that's negative 2. That's x in between negative 2 and 2. And I'll show you how to write these now. So the last piece would be x squared again. So it's x squared, go right to go down, minus 4. And then this is going to be for x greater than, and so I go control this one right here, greater than, oh, should be greater than or equal to, right? So control greater than or equal to 2. Now I made a mistake on these, so I can go back and change these. I don't want to include these, so it's going to be less than, and that's x is in between. Okay, let's see if this works. Sure enough, there's my piecewise function. Does that look identical to the other ones that we had? Absolutely. Absolute value function. Okay, so that's how we split it up into pieces. If you want to hang around for the rest, for the calculus portion, you can. And what we're going to do is just take the derivative of this function. So if I look at f prime now, f prime is just doing it by its pieces. And so if I take the derivative of this, this would be 2x. If I take the derivative of this, I did something wrong here. I'm sorry, I wrote that wrong previously. But this should be 4 minus x squared. If I take the derivative of that, that would be negative 2x. Now, which intervals is this on? Well, I'd have absolute value, and then I'd have the 2. What about this equal sign? If I take the derivative, can I include this equal sign anymore? Well, looking at this point and this point, I don't think that the limit from the left-hand side is equal to the limit from the right-hand side of the slope or of the tangent line. And so I can't include 2 for this. And so I'm going to end up with this situation here. So outside of 2, we have 2x, and then inside of negative 2 to 2, I'm going to have negative 2x. Those are going to be my two slopes of my tangent line. So that is my derivative. And so, in other words, if you take the derivative of a piecewise function, you just do it piece by piece. That's all. And you really don't have any equal signs anymore unless the derivative from the left will equal the derivative to the right on these little, well, wherever these little broken intervals are. All right? So I hope this helped you with piecewise functions. I'm sorry about this mistake earlier, but I think this will work for you. Thank you very much.